FDM 3D printing is super empowering for folks like you and me who want to make things at home, which previously, 10, 15 years ago, could only be made with injection molding of plastics. But there are two major problems with FDM 3D printing. The first of which is the fact that it's not as strong as injection molded parts. In the Z direction, with those layer lines stacked the way they are, FDM parts are always going to be weaker, at least in that one axis. This is something that we could overcome theoretically in the future with 5-axis 3D printers, but there's going to be challenges with the part geometry involved in that as well. So it's going to be pretty hard to overcome that problem. The second problem is the fact that 3D printers are slow. Take, for instance, this Ender 3 Pro, which I have heavily modified here. It exemplifies the problem. Moving beds. Beds should only move if they have to in the Z direction where very little movement occurs. The fact that this bed is constantly moving back and forth with the part on top of it, the part weighs a bunch, the bed weighs a bunch, the detachable print surface here weighs a bunch. Everything that you're looking at is weight that has to move. And if you know Newton's law of inertia, things in motion tend to want to stay in motion, you'll know that that's a problem. You want to limit the amount of weight which moves back and forth. And sure, you could put more power behind it, bigger stepper motors, thicker belts, that kind of stuff, but those are band-aids trying to sort of alleviate the core problem, which is the fact that this design is not as good as other designs out there. But it is cheaper to make. There's a whole lot less going on with this frame, and the Cartesian X, Y, and Z motion of the printer makes things pretty easy to calculate. So up until recently, 8-bit boards have been the norm and the standard, and that 8-bit chip, from like 1985, when 8-bit chips were state of the art, that chip was doing just fine to control these printers. On the other hand, you have this Delta printer, and this is my Anycubic Castle. You can't even buy this printer anymore, but this thing doesn't move the bed at all as it's printing. You have this thing called an end effector, and there's this alien motion where these vertical trolleys end up controlling how the end effector moves around. I love Deltas. They're absolutely the coolest 3D printer that you can get, just because of how, not something that we would understand intuitively. How does 3 X, Y, and Z motors, but they're not X, Y, and Z, like, orthogonal to each other, sort of in a triangle, hence the Delta name, right? It's just so cool. And these print more rapidly because there is not a whole lot of mass that you're throwing around as you're printing. The problem with Deltas is that they tend to be more expensive because of the frames. And my favorite Delta would be my Tevo little monster, and that thing cost almost $1,000. You can't even get it anymore. Actually, I think there's one site still selling the remaining stock for like, $1,200 or something. It's too much money. So wouldn't it be great if we can get a Delta that actually worked? If you guys watched the last video, you know the problems that I'm having with this old Anycubic Castle. There's a reason it's no longer on the market. But wouldn't it be great if we can get a Delta with a similar print volume to the the Creality Ender 3, but also at a similar price point to the Creality Ender 3. So then we would be able to print quicker with the same quality and also have a much cooler movement system, something that we can show off to our friends and be more proud of and just, love our 3D printer that much more. Well, we have a contender. This is an Flsun Delta high-speed printer, and it looks like it's going to fit the bill. So let's get this thing unboxed and start to run it through its paces and see if it can deliver. Unboxing this printer reveals that it's barely a kit. It's a printer which was fully assembled at the factory and then broken down into 5 major components for shipping. So it appears that gone are the days when we have these crazy kits coming from China where every single piece needs to be assembled by the end user. And that means that you're less likely to make mistakes in the assembly process. In fact, assembly is going to be so easy that the instruction set is just a single page here with this little addendum. But before I build the printer, I've been looking over the sub-assemblies, and let me tell you guys, things are looking good. Now, I haven't built up the printer yet, and I haven't tested it yet. There's usually an Achilles heel, some little mistake or thing that the designer or the manufacturer overlooked with these printers from China that really sort of, it hurts the printer's functionality. So we're gonna look for that Achilles heel, but at first blush, this printer is worth way more than the $230 price tag. And let's compare it to the Ender 3 Pro, which was the printer that I showed here in the beginning. That printer currently costs $300, and there's no way that that printer is worth $70 more than this from the components and the quality here. So Flsun looks like they have a total winner on their hands. I'm really excited. So let's dive into this. This is the lid for the printer here, and it houses the power supply as well as the control board. So let's open that up, take a closer look at those things before we build up the printer and do a test print. Opening up this box reveals some pretty decently high quality wiring. All of the ends are crimped and shielded with no soldered tinned leads going into screw terminals. Taking a look at this power supply, the first thing we need to do is change it to 115 volts AC power for the United States. And now let's talk about what this power supply is. So it's a fanless, brand name 24 volt power supply. And that's awesome. So it means you can have silent operation. This Cheng Liang brand is not Meanwell. It doesn't have quite the brand recognition, but it is a design house and manufacturing plant for good brand name power supplies. So that is awesome to see. And then the control board here has this 32-bit ARM processor. And the thing that you know I love to see, that is detachable stepper motors. Now, stepper motor drivers. Now, these white ones here are most likely going to be clones of the Trinamic, even though that's illegal because Trinamic is patented technology. These are probably clones because that's all I've ever seen coming from these Chinese companies, these Chinese products. But if we take a look at that, nope, I'm seeing the genuine Trinamic logo. So that is a genuine Trinamic stepper motor driver from Germany. Fantastic, fantastic. God, this is just getting better and better the deeper I dig. This printer is super impressive. Well, as good as this printer is, there are still some corners which have been cut. This is a Polu A4988 stepper motor driver. It's basically the cheapest driver that you can get. And of course, the extruder motor is going to be run off of this driver. So instead of spending the extra $7 or whatever it cost them, $4 for the expensive, awesome Trinamic stepper motor driver, they're going to put this cheap one there on the extruder where they think we won't notice. Now, it's true, we wouldn't notice for quality. There's absolutely no difference in print quality, but you hear it. These A4988s are loud, and it's stupid. Like, just spend the extra dollars. If you're going to make such a high-quality printer, don't cut any corners, seriously. Say hi to the people.
Hi.
And say, hey, that's it, we're done.
Well done.
We're done, that's all it took. All right. This is the plug that plugs into there, and then the sensor, this is your height sensor, and it basically just magnetizes to this little boss that sits here, and then the sensor is directly beneath the nozzle. Really cool stuff. And another great little usability feature is the fact that all of the screws that I had to put on the printer in order to assemble it were all exactly the same. They're the same size screws, so there's no confusion about which screws go where. You can see those right there and up on top as well. So pretty great foresight by the designer. The printer's fully assembled. Now it's just time to get my satisfaction. By peeling off these plastic stickers here, there's one, and then the other one is up here. So as we can see, this print surface is an ultra base glass, Well, it's a tiny little issue, but I was just trying to run a bed mesh compensation algorithm, and the Bowden tube here got hung up on this bolt, and it couldn't go any more to the left. So the solution is pretty easy. I just need to shorten the Bowden tube. So this was all the Bowden tube length that I needed to remove. It no longer will bind up, so that's solved. Well, this is stupid. Do you hear how loud this printer is? The microphone's up here, so probably this fan's not coming through as loud as it really is. This is actually quite a bit louder than the I don't know, the board cooling fan up here. But there's silence. That's what it should sound like. There's the hot end cooling fan, pretty freaking loud, and then there's your board cooling fan, which are like two different frequencies, so they make it seem even louder. If they were the exact same fan running at the same frequency, it wouldn't be that bad. But this is, I mean, if you're going to go to the trouble to give us a fanless name brand power supply without a fan, the least thing you could do is source some high quality quiet fans. So this is quite miserable to be sitting in the same room as it. I mean, it's not any louder than my Ender 3 Pro, but come on, China, quiet fans. How many times do I have to say it? Give us quiet fans. Speaking of stupid, let's talk about inertial mass. See this cover? It's purely decorative. So you've got this metal cover over the pulley wheels here for no good reason. I don't see, it's just decorative. So that's weight on all three of those trolleys that you don't need. And the less weight you have, the faster you can print. And also, this piece here, made out of metal, does not need to be so heavy duty. All it's doing is holding the fans in place. If the printer's sitting idle and there's no heat here in the nozzle, why is that fan trying to cool the heat sink on the J-head? That doesn't make any sense. Something I'd like to change in firmware. So let's run the auto calibration routine on this printer, which means it's first going to do the frame calibration twice, then it's going to do the mesh bed compensation algorithm. Pressing this button here, then auto level again, and confirm will start the routine. Then we'll go over here, and we will send the same command on my Delta printer that I set up with RepRap firmware the other day. You can see just how much faster my console is with the Duet control board installed into it. And what makes it faster is just some settings in firmware. So I would really like to be able to change those settings on the Flsun. Unfortunately, the control board that it comes with is completely locked down and proprietary. They don't give you any control over that system. Next, we click the Move Z0 button and confirm. That will move that down to where it thinks Z0 is. Oh, that was close. That could have been a disaster. All right, we don't need this anymore. Then we adjust the Z. So we'll stick the paper under there and we'll drop the Z until it hits. And we're done. So it's printing. Listen to this noise. Yeah, did you hear that? So that is the sound of the extruder stepper motor here spinning rapidly. And the reason it makes that high-pitched squeaking noise every time it does a retraction move is because of that cheaper stepper motor driver, the A4988. So that's what I'm talking about there. So $7 or $4 or some minuscule amount of dollars to make the printer that much quieter. Of course, they could have also spent another $2 and made the fan noise so much quieter because the stepper motor drivers driving these axes are silent. I can hardly even hear any noise from the movement there. Speaking of stupid things, there's the screen where you interact with the printer, and here around the backside is where you have to put this finicky little SD card into the printer every single time you want to load a print in here. So let's send this print to do its deal. That one right there. This is real-time printing. This is not sped up. So very, very fast. The outlines are a little bit slower just to get a better quality on the outline there. So while this test print is finishing up, let's talk about a few of the remaining bits on the printer here. First of all, this Titan extruder. Now, this isn't exactly a knockoff or a clone of a Titan. It is very similar in design, but it's changed up enough that I would say it qualifies as not a knockoff. It's okay. I have a strong stance against clones and knockoffs. And it's not even badged or sold as Titan. but that's clearly what it is. And it does make noise whenever there's a retraction move down at the print head, but that could be alleviated if it wasn't a geared extruder. However, geared extruders are nice for when you would get filament jams, and you are likely to get filament jams in this nozzle when printing at very high speeds because it's not a volcano nozzle. So the filament being forced through there so quickly could jam up the nozzle. So that's why a geared extruder is especially necessary and nice to see on this printer. Now let's talk about the extra things that come in the box. The ubiquitous putty knife. This one's very dull. You'll need to cut a sharper edge onto that. Not razor sharp, but almost knife sharp in order to easily pop those prints off the bed. There's a very nice flush cutter included in the box, and a USB drive that I have not yet used, some extra screws, the USB cable, some other tools. We have a screwdriver and the Allen keys and some zip ties and the nozzle wrench. And then of course there's these extra decorative pieces of metal that I've removed to save moving weight. And of course, don't lose this. I don't know, maybe I'm gonna have to figure out some sort of a magnetic mount to keep it here on my printer where I'm not gonna lose it for whenever I need it. But yeah, that's everything that comes on there. Also extra are the stupid vinyl, things there. I don't know what to call these little inserts. They're just decorative, and I think the printer looks much better being all black, so we'll just leave it like that. And yeah, everything you need is included in the box. If you don't have any other tools or 3D printer stuff, you can definitely get up and running 3D printing with just what you see here. The printer came with this mess of PLA filament. Of course, it's all tangled up because that's what happens with these loose spools. But yeah, just get a roll of PLA filament and you'll be off to the races. Now, I do want to do some upgrades to this printer, and the first two things I'm going to do are adding fans. So I'm going to add this larger fan here to the board and power supply cooling. So I'm going to replace the small fan. This will be more quiet. And I'm also going to add this Noctua very silent fan as the J-head cooling fan down here on the print head. So that will quiet it up quite a bit, and I should be able to just put these two 12-volt fans on there using a buck converter step-down voltage regulator, even though the board is 24 volts. So those fans currently on there are 24-volt fans, but I'll get these nice quiet 12-volt fans installed on there. Watch this. I'm going to decrease the speed, and every time I tap the button to decrease the speed, it's going to jitter the tap, tap. See, I'm doing that by, it's overrunning the buffer. Running the controller here is making that pause, and that has consequences in your print. I was printing at 300% speed, so we're getting down to a reasonable speed here, but I mean, look at what I'm doing to the printer. I just finished this print, and there's these other ones that I did, so let's talk about all these test prints. And we'll start with this one that we were just doing, and you saw how I've got some funkiness going on here with the very top. That was where I was just, slowing it down from the print speed of 3000. But I had that same problem down lower down here where I was messing with. All those little boogers are basically moments where I was messing with the screen as it was printing. But what we want to see here is a moment where the light shines off it, and we can ever so faintly see a little bit of salmon skinning. I don't think it's salmon skinning because all of the loops kind of head in the same direction. They go the same way the whole time. So I think it's maybe something in my slicer, or maybe the way that I chopped up the polygons to make my mesh to import into the slicer. So yeah, there is zero salmon skinning artifacts on this printer. That means that this printer prints as good or better than the Ender 3 out of the box, especially with the automatic bed leveling, where you don't have to fuss with getting that first layer right. Once you set it up, it just works perfectly. Yeah, this is better out of the box than the Ender 3. So let's take a look at this print here. This is the usual test print that I do, and you can see again, no ghosting off the sides of those letters. The overhang there looks as good as anything, which is surprising because that's single-sided part cooling. So that single-sided part cooling looks as good as the results that I normally get from double-sided part cooling. And that spire looks fantastic too. Of course, all spires will eventually sort of fail and not look so good, but instead of getting the normal, like just icky all over, I'm seeing sort of these shifts. So you got a big chunk of those layers that are shifted to the left, then shifted to the right, then shifted to the left again. So that looks really good. I think that might be, if not the best, then it's tied for the best one of these types of test prints that I've ever done. This is the print that comes with the printer, and you can see the tolerances are there. It works quite well. And then these two prints I did at different speeds. They're the exact same print, exact same file. All I did in my slicer was slow this one down. And what you can see is it looks kind of like a screen door. And yeah, I can breathe through it. So it is definitely not going to hold water. And the most interesting thing, I'm hoping this can come through on camera, is the bottom. So what we can see is the one that was printed more slowly, the layer lines, or they're not even layer lines, the lines themselves are stuck together better because there was more time that nozzle dwelled over the line for a longer period of time, which allowed each line to sort of merge with the line next to it. Whereas when it was printing at 100 millimeters per second like this, those lines didn't have enough of a chance to bond to each other before they sort of sprung back into the round shape that they were extruded out of the nozzle in. So yeah, printing very quickly has a slight bit of under extrusion. We'll call it under extrusion. That's not what's going on, but yeah. So you know maybe you don't want that print that fast. So maybe you want to stick to the 40 to 60 millimeters per second sweet spot for printing speeds. Yeah. All in all, this printer might be the best one that I've ever seen straight out of the box. And it's time to do the numbers. So for those of you who haven't seen this before, this is my attempt to numerically describe these printers by breaking them down into all their constituent components and giving them numeric scores for each of the components. So I'm trying to be objective here, but there's always a degree of subjectivity. The Teva Little Monster, still the highest scoring printer that I've ever gotten my hands on. I have not yet reviewed the E3D tool changer. That's absolutely going to surpass the Teva Little Monster. But the problem with the Teva Little Monster was that it made terrible prints out of the box. It had a really bad control board, a clone of a Western design that it was really bad. So without doing work to it, this printer couldn't live up to the number score. But once you did the work, it was an amazing printer. So the Artillery Sidewinder, on the other hand, which is in second place, I would actually say it's in first. You can still buy this printer today, and it's got a really high score and a decent value proposition. It's not too expensive there, $379. So 20.1 is the value proposition there. Next down on the list, we have a 24-point value proposition on the Two Trees Sapphire. That's that smaller Core XY printer. I love that printer too. Also a very good printer. And third here on the list now, we have the Flsun Q5. That's this Delta printer that we're looking at today. And it's got a pretty good score of a 70, and the value proposition is higher than the first and second place printers. In other words, much more bang for your buck on this printer. Now, saying that, you can still go down to here to the, the actual Ender 3, not the Ender 3 Pro. There you go, 37.1 is the value proposition for the Ender 3. The Ender 3 Pro, I really don't think anybody should buy that printer. Only a 27.9, so you'd be much better off buying this Flsun Delta instead of the Ender 3 Pro. Yeah, it's a better printer overall. So there you have it. Those are the numbers. Let's draw some conclusions then. This is an amazing printer for the price. It's the lowest cost, most highly functional Delta printer that I've ever seen, period. Even my Ender 3, which cost almost $1,000 when I received it, didn't make prints anywhere half as good as this one straight out of the box. I had to do tons of modification to it to get it up to this level. So we've never seen a Delta printer that works this good from China at this price. This is just $50 more than an Ender 3, and it produces the same print quality at the same speeds as an Ender 3, but you can up the speeds to be twice as fast as an Ender 3 without any of that inertial mass. Plus, you get that awesome movement of a Delta printer. It just looks so cool. If you're trying to impress people and have something really neat sitting in your room or in your living room or wherever you're going to be showing this thing off, that's going to be way more, have a way more wow factor than an Ender 3 or even a Prusa for that matter. Yeah, so I think this is the must-have printer for 2020, hands down. It's awesome. But that's not to say it doesn't have any problems. First of all, the fact that it's a Delta, this is a 235 millimeter bed. This is what you find on the Ender 3. And yeah, it fits in the frame there And basically the bed on this printer almost goes edge to edge, but you lose those corners up there. So that is a significant amount of print area that you don't have on this printer. So if you need to print large parts, this isn't the printer for you. And the other major problem, and this is really the only thing I can fault Flsun for doing, and that is including this proprietary bit of electronics. This is the same electronics that I found on the artillery Sidewinder, and yeah, that printer also very good, but also the electronics, they're locked up and proprietary. It's a black box, you can't change it. So what's the point in having detachable stepper motor drivers when you're already going to give me trinamic stepper sticks except in the with the extruder? But I can't do anything about upgrading those. Putting a new stepper stick, sure, I can plug it into the board just fine, but I can't get into the software to modify so that it will run and utilize the new fancy stepper motor driver. So I also can't get into the software to modify the homing speed, so that this thing could run through its mesh bed leveling algorithm more quickly. I can't change any of that. You just have to accept it the way that it comes from the factory. And the way that it comes from the factory is spot on. Really, I give it a strong B+, if not an A-. There's not much that needs to be changed about this printer. Still, the fact that they've taken the control away from me with this proprietary stuff, I'm not happy about that. But if you don't own a Delta printer already, what are you waiting for? This is the one to get. Hopefully, this won't get lost in the current crisis that we're in. I don't know how it's going to work going forward, shipping stuff from China. We live in some uncertain times, so you might want to get this thing while you can. Who knows if Flsun as a company is going to be around after this. I don't know how any of this works, but this is a great printer. You should get one as soon as you can if you're in the market for such a thing. All right. There is a link right there to my Patreon page. I would really appreciate it if you supported me there, or go ring the bell, subscribe and ring the bell. That helps me out a lot as well. And here is a video that you might want to go watch. So thanks for watching. See you next time.